Before any modeling or deliverable creation can be performed, the data should be checked for blunders. These can be in the form of incorrect point IDs, missing feature codes, wrong backside points, and many other errors. The first thing to check is the project settings. Here you can find all the user selectable options for performing computations, tolerances, view windows, and other important information. One of the common mistakes in the Office workflow is using incorrect coordinate systems between the Office project and the field data file. Here our coordinate system was selected as a default scale of 1 when we imported the JXL with survey stations. This lets the Office technician know that the field surveyor collected this data in some sort of local ground system. Working with both local and global coordinate systems can cause issues in the Office if not properly noted. To demonstrate this, we will import the JXL containing the GNSS data. Select the Import button in the Home ribbon, which will bring up the Import command window. Here we'll select the GNSS JXL and select Import. The first dialog box displayed asks the user to define a geoid. Typically, geoid files are very large and can slow down the field software. Trimble Business Center, or TBC for short, allows users to create and export subsets of a large geoid for use in the data collector. This can be seen here in the Home ribbon. The geoid used in Trimble Access during the field survey is a subset of the geoid 12B conus. The next dialog box notes that there are duplicate point IDs between the project and the data file imported. There are several ways to resolve this. You can rename the imported points, merge them, or create duplicates. In this case, we want to merge the points to transfer our local site coordinate scan information into a global GNSS coordinate system. Select the top left box to select all points to merge and press OK. Whenever there is an issue with the import of a data file into TBC, the software will display an option to view an import summary. In the Import Report window, you can see that the number of files imported as well as the file location is displayed. Here our import error is in regards to the unknown geoid file. Once you are finished with the summary, you can save it or exit the browser. Opening the Project Explorer shows that we now have a geoid and a projection associated with this project. The plan view zooms to contain all data now in the project. It is evident that not all of the total station data moved to global coordinates. Zooming into the remaining total station data shows that there is an issue with point 100 and 102. Looking at the data associated to point 100 in the Project Explorer shows that there is a local grid coordinate set on point 100 and an azimuth between point 100 and 101. To remedy this, delete the grid coordinate associated to point 100 and disable the azimuth between 100 and 101. Press F4 to recompute the project or select the red dot in the bottom right corner of the TBC screen. Now you can see that the total station data is connected to the GNSS measurements main. To prevent clutter, I'm going to turn off the RTK vectors in the View Filter Manager. I'll also turn off the total station vectors, point IDs, and the grid. Now notice that there is a red flag in the bottom right corner. This signifies to the user that there are errors or computations out of tolerance in the project. Selecting this red flag brings up the Flags pane. Here some of the point computations and mean angles are shown as out of tolerance. To change tolerances, go to the project settings in the main toolbar. Here you can change the computation tolerances. In this case, we will change the mean angle tolerance to 5 seconds. The reason why we changed the mean angle tolerance to 5 seconds is due to the short sight lines between the backsight, foresight measurements that we performed in this survey. Due to the short distances, 5 seconds in angular tolerance does not create an overall large error. As well, I'm going to change the positional computation tolerance to 0.03. This can vary depending on the type of survey as well as the procedures used to position points. The project is automatically recomputed, and you can see that the angles displayed before are no longer in the flags pane. Our data has been removed with blunders, set to the correct coordinate system, and now we are ready to move on to deliverable creation.